Guys. All right, so my name is Vladimir Burlov, as some of you might know, and during this particular session, I decided to interview a startup. So these two guys have created a really interesting startup that I'm actually personally fond of, and I'm gonna hand it over to them to introduce it, but they've implemented it on AWS using some of the components that I'm interested in and I work with on a daily basis. So we decided to have a quick architecture overview and then a deep dive. I'm going to ask them questions, they're going to ask me questions, and we'll take it from there. So guys, just would you mind introducing yourselves and the company that you created? Artyom, do you want to start?
Yes, sure. So thank you for having us. My name is Artyom. I'm a co-founder of NewsCatcherAPI, and my friend Maxim, who joined me in this journey. And so yeah, basically we created a NewsCatcherAPI. It's basically an API to search for news data. You can make a request with a phrase, and we would return you the most relevant news. You can specify which sources you want. You can specify the date range you want to find the articles about. And basically the API returns you the data. By data, I mean like articles URL, title, summary, publish date. So that's pretty much like searching it for Google, but just at a bigger scale. And we return something structured, normalized, which you can use. The target group for this product is mostly either people who making some kind of a market research where they need to know, for example, how one of the topics, how a company name, something like this got mentioned in news, so they can compare it probably. And also another big market is financial institutions. A lot of financial institutions right now using alternative sources of data because they know that something that happens in politics, in social, in cultural life can trigger a chain of events that apparently gonna lead to some changes on the financial market itself.
Gotcha.
Yeah. So I'm a data engineer, and starting April 2020, I work full time on NewsCatcher.
Awesome. Maxim, do you want to just introduce yourself?
Yeah, so I'm Maxim. I'm also a data engineer, and I work at SiteTrade in Paris.
Cool. Awesome.
I'm the co-founder of NewsCatcher.
Awesome. All right, guys. So let's go over your architecture, and basically, I'm gonna just ask you questions off the cuff, and feel free to answer any way you want, and let's just go on. So, set me on my journey here into your application. Like, feel free to start from anywhere you like.
All right, I'm gonna start describing generally what this architecture is about, what are the main points, and then Maxim probably gonna start getting more deep into details. So basically our API is about the search, so it's about a full text search mostly. So that's why we have chosen Elasticsearch as a core database for where we could store our data. So logically, I would split our architecture into two sides. One side is everything which happens with data until it gets to the Elasticsearch. And the second part is the API build, which allows end user to query our data to retrieve it. So basically on our architecture design here, you can see Elasticsearch in the top right corner. So basically we have a pretty few stages, how we collect, clean, normalize, deduplicate our data right here. Yeah. So I would say,
Quick question for you. So you ingest everything into Elasticsearch, and then in DynamoDB, I'm assuming you have a list of all of your RSS feeds, right?
Oh, yeah. So that's exactly like this. So our task here is to aggregate data from thousands of different sources.
Okay.
And we are small. We began as a side project, and we figure out that the easiest point of easily collecting normalized news is basically by using RSS. So if someone probably knows RSS, it's something which was really popular like 10, maybe even 20 years ago, but it still works. So basically RSS, I think it stands for real simple syndication, but I think no one knows exactly what it means. There is no normalized way. So RSS, mostly used by news websites. RSS is, I think, an XML file which got updated once in a while with the latest news. I think it was invented probably so that you could subscribe to RSS. I have some RSS feed parser where
Right.
you could yourself subscribe to some RSS and get all the notification from different news websites in one place.
I'm sure a lot
Yeah.
of us are familiar with RSS and how to use it, but what probably most people want to know is you have a list of some of those items of basically the flow of data. Would you mind just going through the list and walking the user through that?
Yes, sure. So basically, we collected a lot of RSS endpoints,
Okay.
and that is exactly how we get our data. And so yes, you are right. The first DynamoDB which you see in the top left corner is the Dynamo which stores the RSS endpoints.
Okay.
I think I'm gonna give it to Maxim because he implemented the most of code for it, and he could explain you more in details how we process it.
Okay.
Okay, thanks. So like Artem said, we have a DynamoDB table which stores all the RSS that we will use afterwards to extract some information about articles from a lot of news sources. So here you can see the lambda function that's triggered by a CloudWatch event. So for us, it's like every 30 minutes it's triggered. And this lambda will just go inside the DynamoDB table and take all the RSS that we have with clean URL with the rank, majestic rank.
So it does a scan of the DynamoDB table.
Yes,
right?
it does the scan.
Okay.
It's not a query, it's a scan because
Okay.
we need to, for now, we need like the full data.
Okay.
Then we proceed these items. So one item is one RSS. We put it in a queue. And then from the other side, we have a lambda that like consumes a message. Actually, it takes like 5 messages at a time.
Okay.
And it's using the package called feed parser. We use an RSS to extract all the information of articles for each news source.
Mm-hmm.
And we stock it inside another DynamoDB table, which is our like the big one. So which contains like Artem said, so all the information, title, summary, publish date, tags, authors, rights, and some other variables.
Okay. And then there's another lambda function. I'm assuming, is that a DynamoDB stream that
Yes,
gets triggered?
yes,
Okay.
exactly.
All right. And then you populate Elasticsearch with that data. Do you actually go and parse the actual article, or do you just basically replicate the RSS description title into Elasticsearch? Like, do you scrape the websites or not?
No,
No,
we
we
just for now we for our MVP we just did it just with
Gotcha.
information which we got from RSS.
Okay.
Yeah.
And then in that case, so on the other hand, on the other side, you have your customers who access the data through API gateway, which triggers the lambda function, right?
Yes.
So
Yes, indeed.
do you use do you grant them developer IDs, or how do you make sure that basically they have access to your data?
Okay. So first of all, we didn't mention, but all of our lambdas are built running Python.
Okay.
Python 3.6, I think. Yeah.
Yeah.
If I got you correctly, so what we did for our beta, we serve it for slightly more than 300 people at the moment. Is that we actually created one API key.
Okay.
And we distributed for everyone. So we basically didn't. We said it for the beta, so we didn't make a big deal out of it. And right now, so basically one API key which we distribute for all of our beta testers.
Gotcha.
But our plan, what we might change quite soon, and probably for our first release, is actually by using API Marketplace. I find it quite convenient because we do not want to have our own paying checkout processing, any API dashboard on our website, handling, creating tokens, giving end users the API key. And in this case, one solution which I found is that API marketplaces, they allow you to create only one key, connect your API to this API marketplace, and API marketplace will take all these job of handling users, providing API keys to those users. And so basically what happens is that end user make an endpoint to make a call to this API marketplace endpoint. And no matter which user it is, API marketplace handles users and makes always the same call to our system.
So I'm actually not familiar with the API marketplace. Is that something AWS provides, or is that a third-party service?
Okay, yeah. So this is a third party, the one which I like the most, in which I already tested, called Rapid API.
Okay, gotcha.
And it is super simple. Basically, I host all my documentation there. I can
Right.
set up my price, and they take all of this. But they take some flat fee for this service.
So okay, I got you. So one thing that, and the flat fee is insignificant in this particular case, or is it?
Sorry?
So basically the flat fee, right? So the way I assume it's going to work is this API marketplace somehow needs to be integrated with API gateway, correct? Because API gateway needs to validate whether this key is correct or not, valid or not, right?
Yes, exactly. Yeah.
But how does it do throttling? Basically, let's assume that you have 100 beta testers, and one of those 100 beta testers is just killing your API gateway with requests, let's say 1,000 requests per second. Can you throttle that user?
We're talking about the API marketplace case, right?
Well, so let's assume you move to the API marketplace. How is this architecture going to change?
Yes. Okay. Then I got you. So on this API marketplace, the one which I mentioned, Rapid API, I can, for any plan which I create, let's say I create a plan for 100,000 API calls per month.
Okay.
Right. So so this is a monthly subscription. You buy this package. And what I can do on the end of Rapid API, I can set a limit on requests. Basically, it is still 100,000 requests per month, which a user gets, but I can say either set it per second, per hour, or per minute. That's what I can do, yeah.
And the API marketplace, each user is going to have his own key, correct?
Yes, but yes, exactly. So I give one key to API marketplace, and then no matter which user does, for our internal system, we see it always as the same call from API marketplace with the same API key.
I got you. All right. So basically, you still keeping the API gateway there. It's just instead of the users going directly to API gateway, they're going to go to the API marketplace.
Yes.
All right.
Yes,
So
exactly.
what happens if, let's say, somebody finds out the API gateway URL and starts hitting it directly?
So we still have the API key on it.
So you have the API key that's the only API key that you allow, right? API gateway will make sure that only.
Yeah.
Only. Okay, I got you.
Yeah.
I got you. All right. I mean, you could have done all of that with API Gateway as well, because API Gateway comes with all of that functionality. You can throttle and you can do that. But yeah, I mean, if that's more convenient for you, then go that route. Just
Is
FYI.
it?
I think
Yeah.
Go
yeah,
ahead.
you're right. Why we like this using API marketplace is simply because they handle it with users. I don't want to code basically to do some system to issue API keys
I got you.
for the
Okay.
for the end users. Yeah, that's
Gotcha.
why
Gotcha.
because we are boss, like more data engineers, we don't know. Our website is basically a landing page. It's like a landing page builder, and we refer for like for checkouts, for pricing, we're gonna refer to this API marketplace. So in this
Gotcha.
case, we don't need to do our own website.
I
Yeah.
got it now. Okay, so basically they take care of all the business side plumbing for you, and then they allow the users to
Yeah.
register, and once the user registers, he gets an ID, some kind of an
Yeah.
API key. I
Exactly.
got it now. Okay, all right. So that
Yeah.
takes care of all of that functionality. Okay, it's a great idea. All right. So, question for you: how many RSS URLs do you have?
So for now, we have like for our MVP, we had around 5,000.
Okay.
So we just took like the most relevant, the most popular news sources per country. And now we were kind of increasing the number of the RSS. So we found other ways to found it, to retrieve it, to stock it,
Okay.
like the RSS themselves. So we will have around 50,000. Is
I
it
got
correct?
you. Okay. So
Yeah,
one
something
thing
about
to
it.
one thing to consider in that case, because you will need to, so from the way you're set up right now, you have a CloudWatch event that triggers a lambda function every 30 minutes that scans your DynamoDB table. So
Yes.
eventually, if let's say you have 50,000, then you might have 100,000, then you might have more. You might want to consider some kind of way to aggregate those RSS feeds into, let's say, objects that can be easily read and processed upon. So instead of scanning your DynamoDB table constantly, what I would do as an example, what I would consider doing is let's say I have 100,000 of them, right? So I would have 100 objects that I would store, whatever, maybe in S3 even, with each object would have a list of all of those RSS, let's say 1,000 RSS feeds, URLs as an example. So I would read the objects versus I would, scan, let's say, the DynamoDB table on a consistent basis. This is just a cost concern that I would have. Let's say 100,000 is not a lot, but let's say you have 1,000,000. So you have 1,000,000 RSS feeds that you need to scan on a consistent basis every single, basically twice an hour. It might add up. You might want to look at how to optimize that particular kind of architecture. That part of it.
We had an idea. Maybe you will confirm that it's a good way to optimize. So we thought about separating all the RSS about the priority and the importance of each news source. So we said to ourselves we can separate them by 3 groups, and we will call one group. So actually, instead of scanning the first DynamoDB table, we'll do a query on the priority. So 1, 2, 3, the priority group, like the group, and then like every time when the lambda will be triggered, it will take just one group and it will proceed the whole data pipeline for this group. And we thought about calling for the first group, we thought about like once, like every 15 minutes, the second group like every hour, and the third group like once a day.
Yeah.
So do you find it like a good idea to?
Yeah, it's a good idea. And again, my only suggestion is due to the potential. It's just an optimization suggestion, right? So think about it. If let's say you have 100,000 RSS URLs, And at this moment, you scan your database twice an hour, and you dump all of those URLs into the SQS queue. If you do a calculation, eventually you will see that there might be some space for optimization, right? So instead of calling SQS or basically dumping all of those, since you're doing a one message per RSS feed, you're gonna have 100,000 messages each time you run it. If you do a calculation, you will see how much it's gonna cost you. Now imagine that's growing to 200,000, 300,000, 400,000 RSS feeds. It's gonna increase in price and complexity eventually, and you will notice it. So as an example, when I was doing the podcast, I mean, Artyom knows, I created something very similar with podcasts, and I didn't even know that there were so many podcasts out there. There's more than a million podcasts out there. So each podcast has an RSS feed, and I never expected it. So eventually, it would have been much more, I would say, complex to just do a scan and a dump. There needs to be a better way of approaching it. Just think about it. This is the only thing. Like I would say instead of scanning DynamoDB for each URL, you scan DynamoDB for, let's say, a category, and each category is represented as a blob in an S3 bucket. And then let's say one of the RSS feeds is no longer available, you regenerate that blob. You know what I mean? You delete it and regenerate it with the correct URLs. Just an idea for you.
Okay.
Yeah, that should be good. But yeah, we have. Yeah, fine. So just you mentioned SQS. I totally got your idea on DynamoDB side. I got it. We also, I think we thought about it. But is there any way you meant also on SQS end, or
is there any way what?
I just didn't get it.
Say it again. Is there any way?
You said that we would have to send. Yeah, we said that we would have to send 100,000 messages to SQS. Did you mean that we could optimize this way somehow, or because in my head I would just change the data?
Yeah. So instead of sending a URL as a message into SQS, you would send a category pointing to an object in S3. So instead of 100,000, you would send, let's say, 100 messages into SQS. Each message points to an object that contains, let's say, 1,000 URLs. You see what I'm saying?
Okay,
and S3. You see?
Yeah, in S3. This is just an idea. This is one of many ideas that you can utilize to kind of think about optimization, because eventually when you grow, think about it this way, right? Right now you might be parsing the most popular RSS feeds. Maybe later on you will start parsing personal blogs as well. So there's millions and millions of those, right? And you're gonna see that you might want to put them in different categories and put them in different with different priorities, and you want to aggregate them because you might feel it.
Yeah.
So you're a startup, right? If you were a huge company, I would still mention it to you, but I wouldn't be as insistent. Let's put it this way.
Okay.
All right. One of the. Can you hear me? Sorry.
Yeah.
Yeah. Okay. Because I just had some issues with the internet. One of the issues we would get in this case is that basically why I like the lambda right here, a lambda trigger on SQS, is because I have so many RSS endpoints, so many RSS feeds to be processed, and if I do it with this many lambdas, I can basically launch thousands of lambdas simultaneously, and they would read the feed and send this data to Dynamo. And I think in your way, if we do it to one message is 1,000 RSS feeds, I just think that in this case, the only thing we could do is to take a lambda and make a loop one after one, which would just simply take a lot of time.
So one approach that you might want to consider, it's called the fan-out pattern. So you take a lambda function, it reads this object, this S3 object, it reads it into memory, or it streams it down, it doesn't really matter. It has 1,000 URLs there. So what it does is it loops through those URLs and kicks off another lambda function with with this URL as the context. So you can do that. You can also do it in parallel. You can multi-thread the call to that particular endpoint, right? So you don't have to do a fan out. You can do a lot of ways. You can achieve this with a lot of ways, right? So first of all, multi-threading is a possibility in Lambda. That's one thing. But you can also do a fan out where you can do a loop and then call another Lambda function. So eventually you will call 1,000 Lambda functions. Or you will call that other Lambda function 1,000 times.
That's
actually interesting because between the first and second Lambda, I put this SQS layer to kind of avoid what you said. I didn't want, so what I could do is my Lambda reads takes, let's say, a few thousand RSS, like 50,000, whatever. And without SQS, it just sends another Lambdas. And I just simply thought that I don't like this way because if something breaks in the middle, the chain is basically broken and it's not gonna go any further. I thought that I just thought that it also could just pressure network. I just didn't get how I didn't think if one Lambda can actually handle this much. And so basically the point is, even if it's 1,000, I was like, if something happens after 50, other 950 is gonna be, they're never gonna get executed. And that's basically the only reason why I put SQS, because I knew that this one additional block here will make sure that all the RSS sooner or later gonna get processed.
Even with SQS, I mean, the idea is you have to have good error handling in your code, right? You have to have try catch statements to make sure that there's error handling. So as an example, if you can even get to that point where nothing happens, even if you don't call additional Lambda functions. As an example, let's say you want to parse an RSS feed, and that RSS feed is malformed, your Lambda function is going to fail, and all the other messages that haven't processed yet are going to fail as well if you don't have proper error handling. You see what I'm saying? So it really comes down to error handling. But yeah, you can definitely do that, and I've done it with multiple of my applications that I've created in the past, where I did a fan out. For what I was doing, I could replay messages. I could there was error handling embedded into the Lambda functions where I set up a dead letter queue for each Lambda function if it couldn't do something with a particular message. So that's also an important aspect here. So all of those things will help you out, but it definitely, if the conversation is we have unlimited amount of resources and money, what's the easiest way of doing it? I would say, yeah, do it this way. Just keep on doing what you're doing right now, because it's the easiest way, right? It's the most simplistic way of doing it. But then you get into the situation where you have millions and millions of RSS feeds, and the only way to process those millions of RSS feeds is to increase the amount of resources that you're utilizing, which means you're increasing the amount of cost that you're incurring. You see what I'm saying? So the only thing is that I'm trying to bring back here is that just think about those elements. You see what I'm saying? Think about the cost optimization while you're implementing your functionality.
Getting on the point of making good catching the errors, I think Maxim did a lot of job on it. And so basically we did try to catch this, and that was the point where it came out. We do not have any logging procedure.
Okay.
And that's what we thought that we might do. And that's one of our questions to you, actually. We found out that CloudWatch itself doesn't provide us a very good vision of what is happening.
Okay.
Maybe we didn't figure out. But and what I think Maxim did and tried to do is to there is a way to connect send your logs to Elasticsearch, to another Elasticsearch platform.
Filter your logs and send it to Elasticsearch.
It's a good idea. I mean, you can do it that way. With CloudWatch logs, it's an easy way to implement this actually. Right, it's just there's a pull down. If you go to URL, yeah, it's actually, you just specified that you want to pipe all these logs into Elasticsearch cluster. You can also invoke a lambda function. I did this as well as the Elasticsearch cluster. There's also a way to invoke a lambda function on your logs to pipe this data to an outside source of log collection, like as an example, Splunk. Even though Splunk might not be the best one to start with, look at some of those log collection like Logly as an example. Look at the pricing tiers, look at those elements, those aspects of each one of those log collections to see which one fits your needs the most, right? Because a lot of them provide free tiers, so you might want to take a look at them and see which one is best from this stance of price for your needs and functionality and data retention.
Does CloudWatch provide some like, not a tool but some way to look at the logs?
Yeah, it does. It has CloudWatch logs insights, I think. So there is a functionality where you can actually do the same thing that you would do in Kibana and Elasticsearch, where you specify query strings and it actually searches the logs for you. So it does definitely do that. Let's put it this way: you don't have to pipe the logs to any outside source. You can keep them in CloudWatch logs, and you can search for what you need to find.
Okay.
That was exactly what we were searching for. We should.
I think it's CloudWatch Insights. I don't remember exactly the name, but it's called. I can look it up right now.
Yeah, I saw. I'm not sure it was inside or not, but I saw the way to just display some information on the on some graphics.
CloudWatch.
Watch.
It's called CloudWatch Insights. I just looked it up.
Insights. Okay.
Yeah.
Okay, CloudWatch Insights. Fine. Yeah.
So what else? What else is because overall I see that it's a perfectly good system here. What I would recommend you guys do, since you mentioned that you're trying to outsource your users to, what's the company?
It's called Rapid API.
Rapid API. Okay, so here's the thing: if they own your users, that means that they basically, it's going to be very hard for you to move to anywhere else. So it's definitely something I wouldn't necessarily recommend. Think about it in this way. Let's say you're not comfortable with their pricing structure. Let's say you grow significantly and you don't like the fact that they are missing some functionality that you really need, right? So what's going to happen? You need to migrate the users away from them into, let's say, a custom-made solution. It's going to take time and a lot of effort. So I wouldn't necessarily use them for user management. I might use them for, API management maybe, but not necessarily for user management. So check them out and see if they allow for user federation. So as an example, you own the users. It might be through Cognito as an example, or through Auth0. That's another service. You own the users. You allow the users to authenticate and register with your service or with your system that you own. You have direct access to those users and the user data, and then they can kind of federate or log in using OpenID with Rapid API. So check that out as well.
Yeah, to be honest, thank you. I didn't think about it, but yeah. So for sure, I do not have emails of users. I have the way to contact them on this platform. But yes, actually, they own my users. And good thing about this is we're gonna have this problem only if we get some success. But yeah, I do get your point. That I really do think.
But even if you don't have success with this particular idea, you might pivot, and you might have success with another idea. But if you pivot you want to have that user information that is easily accessible.
Yeah.
One way or
Yeah,
another,
that's
you
true.
want to own the user. You want to own the customer data. Make sure that you are the primary owner of that customer data. Make sure that you own it.
Yeah, because at the moment right now we do, because this is our website where you have to leave your email, and we would give, but yeah, then after the big release, we would say this is the platform where you can use it, and yeah, so people can
Exactly.
subscribe, and we don't
Exactly.
know,
Exactly.
we don't know about them. Yeah.
You might add additional features, and you might do a lot of other things that Rapid API doesn't give to you out of the
Yeah,
box.
for
So
sure.
definitely own the
Yeah.
user. Just
Yeah.
use Rapid API for the functionality that they provide. Make sure that you don't rely too much on any one of those third-party providers, right? So make sure that you own, like divide and conquer, right? So make sure that you own the majority of it. Nobody needs to have
Yeah.
leverage in
Okay.
it.
Okay.
Yeah.
So what else here? So
Talking about, so
go ahead.
yes. So as you can see, we have this red phrase saying "what if fails," and that's basically I think one of our questions there.
I
But
think
so before starting, I would
I
take.
think that list of steps is covering it. You want to close it maybe for a second? Ah, yeah, I do see
Oh
it.
yeah,
Okay, yeah,
I
yeah,
see.
yeah, I see it.
It's just here.
I
No,
got
no,
you.
no. No. Yeah, you can see it. Yeah. Yeah, but so to get to this point, I would take just a minute explaining a little bit about Elasticsearch and why I personally love it, and about the drawbacks of it. So Elasticsearch, as it says, it's the best database for searching, especially for the full text search. It is very complex, in my opinion. It's very unstable, but you can tweak and change it in such a lot of ways. You can make it a perfect tool for your solution. But so there is one thing which you should know about Elasticsearch: if it does fail always, which means that at some point it can just crash. Doesn't matter why. One day it will. Which leads you to the point that you cannot think about Elasticsearch as you can think about Dynamo or about Postgres, MySQL databases. It is a database which cannot be your primary source of data,
Yeah.
because you would need to so we need a copy of this data somewhere.
So your
And
question
so
is
what we did is
what you do in this case, or like you have a question there. What if it fails? What if Elasticsearch fails, or what if something else fails?
oh
Elasticsearch.
no. So I just said about Elasticsearch, and I will get to
Okay.
this process which we have. Basically, so when we collect data from RSS feeds on the second lambda, which you can see in the middle of the schema, it sends new articles into DynamoDB. More precisely, what we're doing is, I think we're making we hashing title and URL, and we keep it as our primary key in DynamoDB. DynamoDB has a feature which makes it a great deduplication tool. Basically, you say if ID already exists, you just neglect it. You do not take it in, which is I don't know, which seems very logical. But so basically, every time we're processing RSS feed, there is a great chance that a lot of articles in this RSS, those didn't update. So we have already seen it. And in this case, we send this data into DynamoDB as is, and Dynamo accept only new data records. Important part here that only those new data records are going to be treated as new inserts. And we have lambda trigger set up on the insert,
Okay.
which means that DynamoDB is this wall which takes all the task onto the duplication. And so we have a lambda which takes new inserts. It's by DynamoDB streams, and there's a Python lambda which transforms a little bit this data and sends it in the correct form into Elasticsearch.
Okay.
Yeah. So I think one small point here, which is also an important one, is that it's really great that we can duplicate our data on DynamoDB side, because with this huge amount of data, I would say 90 to 95% are always duplicate.
So
And
hold on.
Elasticsearch,
So let me ask you this. So how did you solve? I thought you were gonna tell me how you solved the "what if it fails" problem.
okay, and yeah, and here we come to the point that this lambda can fail. The lambda which transforms data from DynamoDB into Elasticsearch, if it fails, it means that I have my record in DynamoDB, but I do not have it in Elasticsearch, and it will, if I don't have any other thing, it will never get there, because this lambda takes only new in-search records
But
from the DynamoDB.
aren't you using DynamoDB streams?
Yeah,
Yes.
so it's a DynamoDB stream on insert. So Lambda waits for either 100 new items or 15 minutes.
Okay.
So Lambda takes those batch of 100 new documents. And if something goes wrong there, it might be our mistake on the code, or actually Elasticsearch is under big pressure, so it's not going to allow new inserts. One of the data node will not insert it. And in this case, if this lambda breaks, if it dies, which it means that the batch of 100 articles which stayed in DynamoDB but didn't go to Elasticsearch will just stay in DynamoDB. So we need to find a way to
So first of all,
reprocess those
you have the ability to set up a dead letter queue for that lambda function. That's first of all, right?
Yeah.
Yeah.
And that will help you with some of those issues that you're describing, because those messages will end up in the dead letter queue. Second of all, you can put canisius firehose between this lambda function and Elasticsearch. And what that would do is that would allow the actual, or it would create actual throttling between the lambda function and Elasticsearch. So as an example, let's say you have 50,000 records that this lambda function is trying to store in Elasticsearch. Elasticsearch cannot handle that amount of records. If you have firehose, canisius firehose in between lambda and Elasticsearch, firehose will be responsible for ingesting those records into Elasticsearch. So you just hand it off to firehose and it will do it for you. The only thing to consider is that there's a delay of like up to a minute, I believe, between you telling canisius firehose to ingest something and it actually ingesting it. But it's perfect, right? Because this is not the type of data that you need low latency processing for. So consider using canisius firehose if that's a concern. But overall, if you have the dead letter queue set up, then you're good. Now, the other question that you mentioned is what happens if Elasticsearch fails? Well, Elasticsearch, are you using the Elasticsearch service or are you running it yourself?
Service.
Okay,
No, we're using the AWS.
Right, so you're using the service. So what that means is it has, out of the box, it has the functionality to snapshot your data.
Yes.
And you're good there as well. What I would recommend you do is you have some kind of a logic to figure out when was the last snapshot and when it failed, or basically some kind of a way to figure out what the difference is between what's in the database, what's in DynamoDB, and what's in Elasticsearch. You see what I'm saying? Yeah. But either way, my frank recommendation is like every week or so, or 2 weeks, just to rerun the data from DynamoDB. The reason is quite simple, because as you mentioned, right? So Elasticsearch is a beast of a service, meaning Elasticsearch is it's really interesting how to use it. I love it myself, but in some cases there might be a code problem or something else, and you might just want to make sure that you run through a refresh of the whole index one way or another. So if you think about it, let's say Elasticsearch fails, you have a snapshot of Elasticsearch, it tries to re-import it, and maybe your code didn't figure out it correctly of what's the difference between what's in the DynamoDB table and Elasticsearch, and now you're missing some records. So I would create a job that just completely re-indexes all of your DynamoDB data from that second DynamoDB table. You see what I'm saying?
Yeah. Is it enough? For example, like we had an idea. So for example, Elasticsearch fails, and it does not work for like 2 hours. So it's really down for 2 hours. So we restore with a snapshot, but we still do not have any data for these 2 hours. So we thought about like identify, like the first thing to do is identify the period when the Elasticsearch was down,
Yeah.
like fill it manually at first, and then just take this period, take all the data that were inserted inside the the second DynamoDB table, and just put it in Elasticsearch.
Yeah, you can do that too. Yeah, you can do it too. You can do it. Now, Elasticsearch being down for 2 hours is a completely different problem because it's not supposed to be down for 2 hours. If something happens to the Elasticsearch cluster, if you're using the Elasticsearch service, it brings it up itself automatically. So if it's down for 2 hours, it's a completely different problem that we're talking about. So it shouldn't be that case.
Yeah.
It shouldn't be that case. But if it's down, let's say for 20 minutes, or 10 minutes, or something happens to it, or maybe something wasn't propagated, then those are the things that I would be concerned about, or I would think about, and those are the things that I would that is the reason why I would recreate this cluster every now and then. Think of, as you, Artyom, mentioned, think of Elasticsearch as ephemeral data. Make this ephemeral data or ephemeral data source, right? There's a data source that can be completely erased. Think of it as just an index of your source of truth, which is in DynamoDB. My opinion, but you guys, this is strictly an opinion.
To be honest, I still.
Say it again.
Yeah, I'm sorry. I still didn't get the point of why should I re-index data. I always
because you might
have the snapshot. Snapshot will not be destroyed.
Well, snapshot, you're not taking a snapshot every second, right? The snapshot is done on
every hour.
Every hour. So what happens during that hour? You have to have really solid code to figure out that everything works. You see what I'm saying? That everything was propagated from the DynamoDB table to Elasticsearch.
Yes. Okay. Probably I just misunderstood the re-indexing. What you meant when you said re-indexing. But yes, for sure, that's what we thought. So we will always have this window between the last snapshot and the time of the when it fails, and this window we will need to fill from our DynamoDB. And I think the only problem we had is that, okay, let's say we're gonna make it a bit not perfect, but let's say we just want to take this day. We want to take all the DynamoDB articles of this day and try to reinsert them into Elasticsearch. We keep the same ID, so there will never be duplicates. We can just basically start reinserting.
Right.
I think, Maxim, we had a problem how to retrieve this data from DynamoDB. We figure out that we're just gonna have to scan entirely our Dynamo. No.
So the reason was no. So the solution was to, so for all the items that are failed to enter the Elasticsearch, we created that letter queue, and we actually, the idea was to reinsert them. So I update the IDs inside the second DynamoDB table, and then put them inside the normal pipeline.
So guys, think about it this way: you've created an MVP, right? Are you okay with periodically not having, let's say, a day's worth of data? Yes or no? Or maybe an hour's worth of data, not a day's, an hour's worth of data, or 2 hours worth of data. So the reason I'm telling you about that re-indexing job is I wouldn't worry too much about this logic that does the diff between DynamoDB table and Elasticsearch. What I would do right now, initially at least, is I would create a very simple job, because it's really simple to create a job that just scans the DynamoDB table and inserts that data into Elasticsearch. And then once you insert
Yeah,
that,
I just got, yeah, I think, yeah.
yeah, and then once it inserts the data into a new Elasticsearch cluster, you flip from the old cluster to the new cluster, and now you have all the data. You see what I'm saying? So instead of worrying about how everything is going to be, creating hash keys and or signatures from the last date stamp and things like that, initially for the first steps, you just flip it. You recreate the data from scratch from the DynamoDB table, and you flip the cluster URLs, and you're good to go.
Is it expensive just to scan? Like if you suggest us to scan the whole database that we have, like millions of items.
Think about it this way. In this particular case, your lambda functions only write to DynamoDB, right? So you're not reading from DynamoDB, basically. So what that means is you're not utilizing the read capacity. You're utilizing only the write capacity. So is it expensive? It really depends. And it really depends on how many processes are doing the reading at the same time. But you can probably scan with a minimal amount of read capacity there. You see what I'm saying? You can play around with how long you want the scan to happen, and then at the same time, when you play around with it, you will figure out how much read capacity you need.
Okay. So basically, if I said, let's say 10 read capacity units, or 100, so the only difference will be just the speed. With 10 read capacity, it will do it in 1 hour. With 100, it will do it in 10 minutes, for example.
I mean, it's an oversimplification, but basically, yeah.
Okay.
Can we put these limits on the read capacity? Because
you can put it on the read capacity. You can put it on the write capacity. You have to. When you provision a table, that's what you had to do initially. You had to specify the read and write capacity.
Yeah, but I mean, I thought that if we have like throttling read capacities when we have when we like if we want to scan and the big table and we have just 10 read capacities and it takes more time, so we'll just have like the throttling actions.
Yeah, so you will be throttled. DynamoDB itself is going to throttle you. So your code, if you use the DynamoDB SDKs, your code will be smart enough to figure out what happens during this throttling, right? It's just an exception that will be caught, and you will need to retry. Maybe do an exponential retry or whatever else is the best practice. But at the end of the day, this is simpler than figuring out the diff and whatever else. You see what I'm saying?
Yeah.
My opinion, but guys, don't take it as law. If you want to go the other route, go the other route. It's really up to you.
Yeah. Okay. Yeah. But no, it's really good thing to consider.
Yeah. Also, you're using API Gateway here. If you're not using any of the more serious features of API Gateway, you might want to use HTTP API. HTTP API. But then again, you're trying to use the dev API ID, right? So yeah, you will have to use API Gateway here. So are you familiar with the HTTP API?
Me not.
So it's a new service that the API Gateway team has released. It basically is a simplified and cheaper version of API Gateway. I think it's like 4 times or 1/4 the price. Don't quote me on that because I don't remember. I have to look it up. 1/3 or 1/4 the price. And it just doesn't have all the bells and whistles that API Gateway has, like developer accounts and all the marshalling and nice things like that. It gives you the ability to do JWT token verification by specifying the authorization key and not the key, but the authorization, the signing keys and things like that. But overall, if you're not using most of the more complex features of API Gateway, try to use HTTP API. It's cheaper.
Okay. Thank you.
Yeah,
No worries.
should try. By the way, yeah, our like all this API layer, we do it with Zappa. So this is basically a Python package which helps you developing APIs, serverless,
Okay.
deploying your Flask app. Flask is a Python micro
Yeah.
web framework, super popular. And so basically you write your code, you create your Flask API, and with Zappa you just set up your through AWS CLI your account, and it basically wraps it up, makes all the job into making this zip file, making lambda handlers, and it just deploys it on your account. So we basically don't have to think about
API.
Yeah. In the world of so I still use the serverless framework. I also use the serverless application model framework. Right now, actually, this is a great question. How do you use any kind of framework to provision your resources, or do you do it manually through the console UI? And like as an example, Lambda functions, SQS, DynamoDB tables, CloudWatch events. How did you create them manually?
Everything manual.
All right. So my recommendation.
We don't use it. Yeah.
My recommendation is to script this. Use CDK. That's my favorite framework right now for infrastructure as code. I actually have another YouTube video on that topic.
I know.
Yeah, exactly. So I also created sample code. So use something like that. CDK, Terraform, just straight up CloudFormation, which is I wouldn't recommend it because it's just not as easy. Or use something, basically script it. Make sure that it's declarative, some kind of a declarative framework. And that way, if something, if you want to migrate or you want to create a dev environment, as an example, you'll be able to do it quickly and you're going to be able to replicate it. And you'll also be able to see if there is any drift in configuration. One of you might go into the console, make a change, and bang, the other didn't even know that this change happened. But if you have code and you do the change, make the change through the code, then both of you know that if you, first of all, why the code change was made, and second of all, that something has changed. So definitely consider using infrastructure as code. It's really easy to use, especially for developers, and CDK provides a Python framework as well.
Okay. Yeah. I was a bit scared about it. Like when I saw all this long infrastructure as a code scripts, honestly, and to be honest, just when we are beginners with AWS, and to click actually yourself, it is really nice to see all the configuration, what you can put. But I agree, if you want to be serious and make some production dev stage environments, I think we should use infrastructure as a code tools, because we need to
definitely it's a great idea. It's a great idea to go through the console UI one way or another. Once you do it a couple of times, you're comfortable with all the parameters and everything else, that all the relationships between the features, then code it. That's my approach, at least.
No, that's true. That's true. Yeah.
So I think, like 3 more minutes before my laptop dies. What other questions do you have for me?
I think
I'm kind of good.
You're what? Say it again.
Sorry, I had some drops on the internet side. I said, like, I'm good, but I would like to know some general probably feedback.
Generally,
probably you have something for us to add.
No, I think I mentioned all my general feedback, like own your users, figure out a way to optimize the batch jobs, things like that. That's definitely something to look at. Overall, I think this is great architecture. This is a architecture that I see throughout I would say the industry, or the way you tie them up, tie them together. It's it's a well-known basically approach, right? So you're doing everything correctly. You're doing everything the way you're supposed to be doing it. There's nothing. There are no red flags. Let's put it this way.
Okay.
By the way, for the audience, what's your website? Just tell them.
Yep. So it is newscatcherapi.com.
Okay.
You will have the link in the description because you're gonna put it in. Yes. So the announcement is for everyone. Right now we're in a closed beta stage. We have around 300 people signed up to whom we delivered the keys. We plan to make our, I think, open beta release in beginning of June, and then to have our stable version by 1st of July. So just go on our website. It's completely free. Just leave your email. We're gonna send you the API key, and you can pretty much unlimitedly use it as much as you want. I mean, as long as it's not 1,100 API requests per hour.
Awesome.
Please,
And
please don't do that.
make sure you set the throttling limit on that one particular API. So since it's beta,
Yeah.
you can just protect yourself that way. Guys, it was an awesome interview. Thank you very much. And as always, feel free to reach out with questions. Thank you, Maxim and Artem.
Thank you. Thank you. as
Thank
well
you very much for having us.
for your advices.
All right, guys. Bye.
Bye.